Okay, let's go to page 128 and section 11.4. So this section is a Pythagorean theorem. So when you have a right triangle, so if it's a right triangle, then the relationship between three sides would be a squared plus b squared equal to c squared. So let's do one of the example. So let's do example 11-3. Is that given the leg of a right triangles are 8 and 4, and then hypotenuse would be, okay. Now I kind of, if you can use Pythagorean theorem, but I like to kind of do factoring. So when you have this kind of situation, it's easy if you kind of, especially if number is really large, go and factor out the number. So you're looking for x, right? So go and factor out the 4. So you're going to get 1, 2, and use your Pythagorean theorem. So this will give you square root of 5, right? And then so x will equal to 4 square root of 5. So you can factor out the number. So you can use these to use the lowest number possible. And once you find that out, and then you can just go and multiply by the 4. Okay. So this is kind of the tricks, is make calculation a lot easier. Okay, now Pythagorean theorem, there are a lot of spatial triples that if you recognize, will make your things a lot easier. So if you go to page 130, okay, on page 130 there's a spatial triple. The Pythagorean triples, the most common one is the 3, 4, 5. Okay, so 3, 4, 5. Again, a squared plus b squared equal to c squared. Now, nice thing about the spatial triple is also notice that if you square these, it will equal the sum of the two consecutive numbers. So 3 squared equal to 9. So 4 plus 5 equal to 9. Okay, and if the numbers get large, the way to figure out is you square and you divide by 2 and you go on either side, right? So 3 squared will give you 9. Divide by 2 give you 4.5. And so the integer on either side of 4.5 is 4 and 5. Okay? And so if your next one, if it's 5, so if you square that, 5 squared is 25, and so it'd be 12 and 13. Right? Because 5 squared is 25, divide by 2 give you 12.5. 12.5 you go 12 and 13. So if you go 7, okay, so 7 squared is 49. 49 will give you 24 and 25, because 49 divided by 2 give you 24.5, so it will be 24, 25, and so forth and so forth. Okay, so if you get 9, you square the 9, you get 81. So 81 it gives you 40 and 41. Okay, so this helps you recognize some of the spatial triples. Okay, so you can, if it's odd number, if you know one of the sides odd number, then you can square, then divide by 2 and go on either side. Okay, so again, you go, so for odd number, you square, and you divide by 2, and you go on either side. Okay, so this is kind of the symbol. Okay, so again, if it's odd, you square the number, divide by 2, and you go on either side of the integer. Now, if it's even, you kind of do the opposite. Okay, you divide by 2. Okay, and you square, and you go on either side of that number. Okay, so for example, if you start with 4, okay, so if it's divisible by 2, you divide by 2 first. So 4 divided by 2 is 2. You square, you get 4, and you go on either side, you get 3 and 5. Okay, which is that. Okay, if you have 6, okay, you square, you get 3. Divide by 2, you get 3. Square, you get 9. Okay, and you go on either side, so you're going to get 8 and 10. Okay, which is a double of that. Oh, by the way, this is a primary. Okay, so these are the primary ones. So you can have any multiple of that. For example, like 3, 4, 5. Right. So for 3, 4, 5. So for 3, 4, 5, you can have the second multiple be 6, 8, 10, and third multiple be 9, 12, 15. Okay, so this is also fairly common. Okay, so again, it's just a primary, so you can do any harmonics of it. Okay, and you can times it by 4, you get 12, 16, and 20. Okay, so all this would be considered the harmonics of the 3, 4, 5. And same thing with this one over here, right? So the 5, 12, 13. So if you do the multiple of 2, you get 10, 24, 26. Okay. Now sometimes some of the number is harder to recognize as that, so you can do the factoring. Once you factor some of these, and you can recognize very easily, and so you can do some of that. Okay. And for what I'm saying is that, for example, if you have like 12 and 16, okay, and you're looking for x, okay, so instead of doing the Pythagorean theorem, number can get kind of high. So what you do is you go and factor out the 4, so you get 3, 4. So once you see the 3, 4, you can recognize this is a 5, and therefore x will equal to 20. Okay, 5 times 4 give you 20. So that's how you can get a Pythagorean triple very quick. Okay. And so let's go to the next one. So 4, 6, 8. So 8, again, divide by 2, give you 4. Okay, 4, and you square, you get 16, and you go on either side, you get 15 and 17. Okay. So make sure you're kind of familiar with the triples. So it's really helpful. The one you're going to see a lot would be this one, and this one. Okay, and so this kind of come across fairly common. This one is kind of often also, but the most common one would be these two. Okay, and again, make sure you know how to use this technique. It help you to recognize. Okay. Okay, so let's do some example. So let's go and do example 11-7. It says the leg of a right triangle has a length of 3 over 105 and 4 over 105. What is the length of a hypotenuse? Okay. So again, like what I was talking about earlier, right? So you can factor out the 1 over 105, so you get 3, 4, and what would be, this would be a 3, 4, 5 triangle, right? And so right away, x will equal to 5 over 105, and if you simplify, x will equal to 1 over 21. Okay. So again, if you can do that, you don't even need a calculator for that, right? So again, you can do that. Okay, let's go to example 11-8. If the hypotenuse of a right triangle is 4.25, one of the leg is 2, what's the length of the other leg? Okay, so you have one leg is 2, and you're looking for the other leg, and the hypotenuse. Make sure you always put a hypotenuse on the end, 4.25. Okay? Okay, notice you got decimal, right? So what you can do is to get rid of the decimal, you can go and multiply by, in this case, you want to multiply by 4, right? Okay? You can multiply by 4 to get rid of the, or you can make it into fraction, either way. Okay? So if you multiply by 4, so this becomes 8. I'm going to put this as y. And 4, this will give you 17, right? So again, this is your 8, 15, 17 that you should kind of recognize, right? 8, 15, 17. So y will equal to 15, and therefore x will equal to 15 over 4. Okay? And if you want to use decimal, x will equal to 3.75. So again, by using this method, you even with a complicated number, you don't even need a calculator for it.